Alright, I'm going to show you two ways to solve this problem, or to factor this polynomial, and I'll do it in two videos. So, method number one is to just go about it like we did our previous trinomials. Notice this is a polynomial in the form ax squared, if I can get it in there, plus bx plus c. Not writing very well this morning. 8x squared plus bx plus c. And it's different than ones that we've done previously because the a value is no longer a 1. If you look, we've got a 15 there. Now, that doesn't really matter. We can still kind of attack it just by trying to factor it. We know it's a cubic trinomial. We know it will factor into two binomials. And so we just go at it. Now, the problem we run into is normally in these first spots for us, when a was always 1, here it's not equal to 1. In our previous problems it was. We always knew that these first terms in each binomial were just like x and x, or in this case p and p. But because of that 15, we no longer know that. Now it could be, for example, 15p and p, or it could be 5p and p. Likewise, the 5 on the end fills in these the second term in each binomial, but that could be a 1 and 5, or these 1 and 5s could be flip-flopped. When the 1 is in the position it's shown in right now, the inside product here is 1p. When it's in the 5's in the outside, it's a 5 times 15, it's a 75p. If I were to switch where the 1 is and make this a 5, now my inside product is 5p, and the outside product would put the 1 on the outside, and that outside would be just a 15p. So location of where you put the second terms obviously affects it. And then we have to look at the same conditions. What if we put 5p and p in those spots? So, with that said, if we want to factor it just by trying to grind through it using our products and sums of all our terms, trying to squeeze it out of it, I would probably start this problem by factoring the 5, because 5 at least is prime. Okay, and because it's prime, only 1 and 5, we know 1 and 5 have to be in those last positions. And the only ones then I would play with as I'm trying to get this thing to work out are the 15p and the 1p and the 5p and the 3p, and then their opposites, or transpose them, 1p and 15p and 3p and 5p. So they're the same factors for 15, we're just trying them in different positions. Okay, and now it's just a game of trial and error. I think I've already tried. If I put the 15 in this first spot, this product there is 75. And 75 is nowhere close to that middle term of 22p. That should be right in there. So I'm not going to try that. The next one I would look at maybe is thinking about putting the 5 in that outside spot. If I put the 5 in the outside spot, I get a 25, which I kind of like, because the inside spot then is a 1 times 3p. So I end up with a 25 and a 3, and 25 and 3 certainly have a difference of 22, the middle term. So I'd put a 5p right here. I put a 3p right there. I'm going to erase some of the stuff below here so we can kind of see what's going on. Okay, now I'm going to just go through and I'm going to redistribute and multiply it out to see if this is giving me some numbers at work. My first terms, obviously, if I multiply those, 5p and 3p gives me the 15p squared. My last terms, the 1 and the 5, certainly multiply and give me a 5. This outside product now is 25p. The inside product is 3p. If the 25 is negative, by putting a negative sign in front of the 5, and the 3p is positive, by putting a plus in front of the 1, they add up to negative 22p, which is what I want in the middle. I double check this last sign here. This is a plus 1 times a negative 5, which is negative 5. So this is clearly my solution. Okay, so there's kind of the guess and check, sort of making educated guesses method for solving that.